All right, so we're on the back of our 7.1 notes. We're adding some notes to it. So simple interest is basically just a simple way of finding interest. You're paying 30% interest. What are you going to pay? We just tack it on and use the formula like we did yesterday. That's basically exponential growth. Okay, but compound interest is much more realistic. It's how bank loans are calculated. It's how credit cards are calculated. It is something you have to know to be a responsible, fiscally responsible adult. All right, just for your own personal budget, you need to understand compound interest. So, how does it work? Well, first off, the equation for compound interest is very similar to the equation for simple interest we talked about yesterday, the exponential growth. They change a couple things. First off, many of you don't like that function notation anyways, and A of t confuses you still. Well, they're going to simplify it for you a little bit and just call it capital A. It means the same thing. It's the amount after t years, okay? So it's the ending amount. Now, rather than little a, which is the initial amount, in finance, we call that the principal, okay? It's the principal amount that you deposit into the account, or it's the principal amount that you borrow from the bank, okay? So that's capital P, principal. It still means the same thing as what little a did in yesterday's formula. And we multiply that by 1 plus, and now R is still the interest rate, okay, or the percentage growth rate. But now we take R and divide it by N. I'll tell you what N is in here in just a minute. Okay, and then we still raise it to the T, but rather than raising it to just T, we raise it to the N times T power. So, really the N is the new thing in the formula today. We changed our variables slightly, but it's the same setup, it's just now there's that N involved. Okay? So let's talk about what each item here in this formula stands for. So first off, A is the amount after T years. P stands for the principal. Amount, I'm just going to put original. That's what principal means. It's the original amount you started with. Okay? R is still your growth rate or interest rate. Okay, T is still time, and by the way, that's usually calculated in years. It'll be calculated in years for us in this class.
Jocelyn Sosa, please come to the cafeteria.
And the new part to this formula is now the N. N represents the number of times interest is calculated per year. And by calculated, they call that a lot of times compounded.
Alex Stroud, please come to the cafeteria.
Okay? By calculated, they call that sometimes compounded. All right? So N is the number of times interest is calculated or compounded per year. Okay, so to know that, we also need to understand some of their numbering systems. They're going to tell you that interest is compounded yearly, which means how many times a year? Once, yeah. So if they say yearly, or annually, they could say, that means that N equals 1. If they say biannually, what do you suppose that means? Yeah, 2 times a year. Biannually would be 2 times a year. How about quarterly? N would equal 4 times a year. We could do monthly. Yep, there's 12 months in a year. We could do weekly. How many weeks in a year? 52. We could do daily. Okay? We have to know what they mean when they use that language. Okay? Biannually, quarterly, monthly, weekly, daily, yearly. That is giving you your N value. How many times in 1 year that interest is being computed. Okay? On your worksheet for compound interest. So at the top of the worksheet, they have the formula there for you. Isn't that nice? Number one, if you deposit $500 in an account that pays 1.2% interest, compounded monthly, so what does that mean?
12 times
N equals 12. How much is in the account after 6 months, 1 year, and then 5 years? So we have to do this problem 3 times. So starting out, we have our formula. We are solving for A. Our principal amount was what? 500 times 1 plus, what was R? Interest rate. 1.2%. So how do I put that in the formula? 0.012. Very good. Oops. And that has to be divided by N,
12.
which is 12. Okay, and then we raise that to the N times T, so 12 times, now T is always in years, so if they want 6 months, that is half of a year, so 0.5. I would simplify this down before I do anything else. So 500 times, you are going to need to take your calculator and take 0.012 divided by 12. 0.001, and you're going to want to take 12 times 0.5. That's 6, half of 12, right? I would simplify farther. 500 times 1.001 to the 6th power. Okay, so now we want to actually crunch some numbers. In your calculator, you want to take that 1.001 to the 6th power. You want to do that first.
1.006.
Yep, 1.006, blah, 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 blah. Leave that number in your calculator. Because now all you want to do is push times 500. 503.001. And that is dollars. So after 6 months, we have made an extra $3.01. Okay? Now the nice thing about working these problems is that they change the year on us, but we've already done a lot of this calculation. If I go in and plug into this guy, I know that A equals 500 times, I already know what's in the parentheses. It's going to be the same every time. This isn't changing. 1.001, and now I'm taking it to the 12 times 1 power for 1 year. Right? So, in our calculations, we're taking 500 times 1.001 to the 12th power. Grab that calculator. What do we get? Okay, but then multiply that by 500. Okay. And now we got to do it one more time. Looks like I'm going to run out of space here. So one more time, this time with 5 years. So A equals 500. Again, what's in the parentheses isn't going to change. They haven't changed the interest rate. They haven't changed the number of times it's compounded. All that's going to change is the T value, which is now 5. So that means we have 500 times 1.001 raised to the 60th power. Okay? So then you get, oops, put that in the wrong spot, excuse me.
530.9.
So then you get $530.90 after 5 years.